Okay. Is it fine now? Yeah. I'll just share my screen now. Okay. So what I was saying, uh, we're just starting with a very small voltage, 0.1 volt. We thought in the starting. So P type is connected to a very less voltage. So we thought, okay, D1, there's a high possibility that whenever we will be taking V input as a very small voltage, D1 will be off. Okay. And then we'll see that, okay, D2, the P type is attached to some higher voltage, 6 volt, right? So we'll think that, okay, D2 is in the starting, it is on. We'll check also whether whatever the assumption that we are making is correct or wrong. And similarly, we'll see that for D3, uh, the PN junction is attached to a very high voltage, right? So that will be off, correct? I hope this you would have thought, right? Okay, so we were taking D2 and D3 correctly, but D1 we were taking incorrectly in the assumption. Okay, even though we didn't like progress here, we are just assuming that D1 is off, D2 is on, and D3 is off. And why we have assumed? We thought that okay, this P type of the D3 attached to a very high voltage, so that's why we thought okay, D3 will be off. And for the D2, as the P type is attached to a high voltage, 6 voltage, right? So we thought okay, this can be on, okay, and the D1, as we are just giving a very initial, like very in the starting we are just giving a very low voltage, so that's why we are thinking D1 will be off. Okay, now if we thought okay, this assumption that whatever we have made, whether it's a correct or wrong assumption, let's try to draw the circuit itself. So if we'll draw the circuit, this will be open, D1 is off, so it will be open, and then there is resistance 2.5 kilo ohm, and then this will be short circuited because we are thinking that D2 is on. So D2 is on, okay, and then you have a resistance voltage of 6 volt, and here also this 20 volt, 20 kilo ohm, and then this is open circuit, okay, and then you have a potential of 20 volt, and then you have a resistance 5 ohm, correct, and the potential across the 5 ohm is your output voltage, right? So now VD1, okay, and this, let's for example, this is for VD3. For our, like whatever the assumption that we have made, the all three assumptions, okay, for all three to be correct, the VD1 should be, what should be VD1?
That 6
VD1
volt minus
no no
V out.
no no okay, so no, if you are assuming that diode is a reverse bias, if we have made the assumption this VD1 should be coming out, should be less than 0 volt, right? Then our assumption is correct, right? And
Yes,
there should
sir.
be a, okay, and to have a VD2, like the assumption for D2 to be on, that I, so there should be some I current, and that should be positive, okay. If I is coming out to be positive, then our second assumption is also right. And for the third assumption, this VD3 should be coming out to be negative, right? So if those three combination is coming, then our assumption must be correct, right? I hope this is clear to everyone. Now, let's for example, this was V naught, right? So let's for example, this will be V naught. So this is V naught, right? So let's take it this as a grounded. So this will be V naught. This is also V naught. This is also V naught, right? So can you write the equation, the nodal equation? So if we'll write it, V naught, one current is there, right? One current is here. Here it is open circuit, so there won't be any current in this direction. Only, so I can see there will be only one current, right? Like this. So if you'll write it, V naught minus 6 upon, what is the resistance? The resistance is 5 kilo ohm. Okay, and in the analog mostly, even though so your current mostly will coming out to be in a microampere, the voltage will always be in the, like the volt itself, and then your resistance mostly will be in the kilo ohm. So even though you're not writing anything, like you should not be writing any equation that you're writing, you should not be writing anything in the form like kilo ohm has been given. If you're writing 10 to the power 3 every time, like you're converting into a ohm and then all the current into ampere, so it's better you write everything in the, mostly whenever you will be dealing, at least in wherever you are dealing with the diode and all, mostly the current will be coming out to be in a microampere, milliampere, sorry, and then your voltage will be in the voltage itself, and the resistance that you have, mostly it will be coming out to be kilo. So this will get balanced, okay? Even though you're writing without any unit, in the end will be doing correct. Even though if you write it with the help of 10 to the power 3 ohm, everything, if you're converting, your equation will get messed up, okay? So just have to take care that your current, mostly it will be in the milliampere itself, the voltage will be in the volt itself, and the resistance you'll see that mostly it will be in the kilo ohm, okay? So if you are going with this, like you don't have to write every time 10 to the power 3 or 10 to the power minus 3 to convert that everything into ampere or kilo ohm. Okay, so this is what you should be focusing. Okay, so here also if you'll write it, the equation 1 volt, okay, so V minus 6 upon 5, this is because this was 5 kilo ohm. Now whatever the other thing, the other, yeah, here you have,
Sir,
yeah,
according to the direction of current, the equation will be incorrect, I think.
no,
6
I'm just
minus.
saying the current, no, I'm just saying the current will pass here. Okay, if you're writing the nodal equation, this is V minus 6 upon 5 plus V naught upon 5 equals to 0, right? No, I'm just writing this equation. I'm not writing the case here. I'm just telling that there is only one path of the current to pass, right? The current will pass like this.
Okay, sir.
Yeah,
I'm using
but I'm
the
writing the equation. Yeah, so here you have a voltage, right? V. If the current is passing, so even you can write it anyway, 6 minus V naught, and then you can write it like this also. There is no not going to impact you. Are you getting me or not?
Yes, sir.
Yeah. See, you can write the equation like that also. If the current is in this direction, you can just think of as 6 minus V naught upon 5, right? And then for this equation also, you can write it. So the value of the V naught you'll be getting as same only. Okay. So if you'll just equate it with V naught upon 5, you'll be getting the same. Here also, if you'll write it V naught upon 5, is going to be minus V naught minus 6 upon 5. So both equations are same only. Okay. So what is the value of V naught you'll be getting here? V naught will be, this will be cancelled, 3 volt. 3 volt. Okay. So what I was trying to say, so you got V naught equals to 3 ohm. Now we have to check whether the assumption that we are making was correct or not. Okay. So for VD1 should be less than 0, correct? Okay. So if I have to write the VD1 in the form of V input you have given. So let's, for example, you're writing V naught coming out to be 3 volt, right? From here. So if you'll write it, let's, for example, this is some VD1, okay? And now you have here V naught, correct? And you're attaching some V input here. This is V naught, this is VD1, this is V input, right? If you'll write the equation, what you'll be getting? VD1 is what? V input minus V naught, correct? If you'll just write V input plus VD1 plus V naught equals to 0, correct? So V naught, VD1 will be equals to what? V input minus V naught. Are you able to understand this or not? So, or
Yes.
correct, right? Now, our assumption was what? Our assumption was this should be VD1 should be less than 0, right? Our assumption, we have made the assumption that this is in the reverse bias, correct? So to make, and then we were taking V input as what? V input we were taking as a very small value, right? 0.1 or something like that. So 0.1 minus 3 is coming out to be negative. That means what? The assumption that we made was correct. So the VD1 in the starting will be reverse biased. Okay, until when it will be reverse biased, that also you can take care. So VD1 should be less than equals to 0, right? So V input minus V naught should be less than equals to 3 volt, correct? So that till when it will be in the reverse bias, the diode 1. So the diode 1 will be in the reverse bias till V input minus V naught is less than 3 volt, correct? Because you know that VD1 till VD1 is less than 0 volt, that means this diode will always be in the reverse bias, like till VD1 is less than equals to 0, less than 0, not equals to. Is it clear to everyone? That means what? V input till V input is less than 3 volt, this diode 1 will be reverse bias. As it will be crossing 3 volt, okay, this will be on. Are you getting me or not? Everybody got it?
Yes, sir.
Or should I?
Got
Okay,
it.
got it, right? So that means what? So we input till the time we input. So till now, what we have done, as we input is from belongs to 0 to 3 volt. Okay, our D1 is off. Correct. Similarly, you can check for the current value also. See, the current value, if you'll check I voltage to check whether the diode 2 is on or not. If you want to check it, this is 3 volt, right? So 6 minus 3 upon 5, that is coming out to be positive number. That means I is also greater than 0. That means our second assumption is also correct. Agree?
Yes, sir. Agree.
Okay. Now the third thing, that VD3, that is what? This is 3 volt, 3 minus 20. That is minus 17. That is also coming out to be negative. That means our third assumption is also correct. So whatever the assumption that we have made in the starting, that all three was correct. Is it clear to everyone or not?
Yes, sir.
Yes, sir. Clear.
Okay. So now till 0 to 3 volt, our diode D1 is off. What about D2? D2 is on and D3 is also off.
Yes.
Okay. Now as we input, we'll put it as 3.1 volt. We are increasing that. Okay. As we'll increase that voltage, now we have to see the D1 will be on, right? Correct? Because we have seen that, right? Till
Yes.
3 volt, this is off. As we'll increase the value of V input as 3.1 volt, this D1 will be on. Correct?
Yes, sir.
Okay.
D1.
So D1 was on, D1 will be on, D2 is already on, and D3 is off. Correct? So now the circuit, we have to draw it again. So now the circuit, this will be short circuited because this is on. What about the D2? So D2, how that was? D2 was, yeah. So D2 will be on. So 5 volt, 5 kilo ohm is attached here. 5 kilo ohm. And this is also short circuited. This also we can check. The second assumption that we have made, this is on. Now D2 is on. Okay. And we have attached 6 volt here. Here it was on. Sorry, off now, because D3 we are assuming this to be off, and here we have a resistance of 20 kilo ohm. That is not going to make any difference. This is off, and then you have a voltage also 20 volt, correct? And you have a resistance attached here, 5 kilo ohm, and here also you have a resistance 2.5 kilo ohm. Now this is on. You are attaching. You are giving some V input, right? Above 3, and this is what we have to find. V output upon V input from 3 to 9. So we'll see how that 9 is also coming. Okay, why they have given? They have asked. I don't know. Like directly they have asked from 3 to 9. Okay, can you please mute? Okay, so now, so this is case 2. So case 1 we have seen. Now case 2. So now again this is on, right? So that means there will be current now, ID1, and this will come. The assumption that we have made is now this is on, because we have seen that till 3 volt it was off. Now it has been on. Okay, and this is also on, so there will be current here also. ID2. Yeah. Now and this, okay, this is VD3. Okay. Now what will happen? Now again this is what? This is V naught, right? V naught is the potential across 5 kilo ohm. So again you can write it here. V naught. This is V naught. This is V naught. Can somebody tell me the equation now? The equation you can write it here, like this is attached to V input, right? So you can write it as what?
V.
V naught V naught upon 2.5, right? Plus
Yes, sir. V naught minus 6 upon 5.
upon 5. and 1, you can write it from here.
V0
Right?
by 5.
5. What will be the value of V0 here? If you'll see this, you can just multiply 2 upon 2. So this will get cancelled. So we'll be having 2 V0 minus 2 V input plus 2 V0 equals to 6. Right? If you'll see 4
4
V0,
V0.
2 V input plus 6. Correct?
Yes, sir.
That means what? V0 is what? 2 V input upon 4 plus 6 upon 4. Right? And this is 0.5 V input plus 3 by 2. So your answer, like you can directly tell 0.5 would be the transfer, like the slope that has been asked. Correct? Now,
Yes.
see, okay, so V out, now we know. Now we'll see that from 3 volt till which voltage, our assumption, the assumption that we made that D1 is on, D2 is on, and D3 is off, that will follow. Because this is all dependent on the V input, right? So we have to check all the conditions, right? The second condition that we have made, D1 is on, D2 is on, and D3 is off. Okay, we'll have to check. Okay, so now we'll have to see till which voltage this will follow our case 2. Okay, so now what can we do to know this is V0, right?
Sir, 5 volt at, sorry, 9 volt. Till
How?
9 volt. Because sir, if V out is equals to 6 volt, then diode D2 is on, sorry, off.
Super. Yeah, correct. Super. Yeah. So V out, this V out should be greater than 6 volt. Otherwise, this ID2, our assumption will become wrong, right? So this ID2 should be coming out to be positive, right? To have D2 to be on. That means what? This V output that we have calculated, here the potential of this node is V0, right? Okay, and here you have 6 volt. So that must be, this must be less than, this must be less than 6 volt, right? To have a current from 6 volt to V0, right? That means what? This should be V0 0.5 times V input plus 3 by 2 should be less than 6 volt, correct?
Yes, sir.
Yes.
Right? Okay, so that means what? V input should be less than what? 6 minus 1.5 upon 2. So V input should be less than 9 volt. Correct? That means what? As V input, the first condition was what? As V input was from 0 to 3. Okay, there was some condition about D1, D2, D3. That D1 was off in the starting, this was on, and this was off. Now it has crossed 3 volt, right? So from 3 to 9, this became on, and this was already on, and this was off. Now as we are moving above 9, okay, 9 to some X voltage. Now what happens? This will be on. This on will become off, right? Because it will cross 9. Are you getting me? As it will cross 9, this V0 will be less than 6 volt, right? That means what? Sorry, more than 6 volt. That means this will be off now. So D2 now become off. This will be off. And this was already off. Now what will be now we have to find this X also, right? Till when? Till which V input this D2 will be on. See, this has changed, right? D1 changed, D2 changed. Now D3 will also change. Are you getting me? Everyone able to understand this, right?
Yes, sir.
So now we have to calculate the value of the X. Now we have to write the circuit again. The circuit was, this was short circuited with 2.5 ohm, 2.5 kilo ohm. Now we have a resistance of 5 kilo ohm, and this was on, off now. D2 is off now. So this is short circuited D1. This is open now, okay, with some potential of 6 volt that is not required now. And then you have a 20 kilo ohm, and this is also off, okay, and you have a 20 volt, okay. And now we have a resistance of 5 kilo ohm, and this is V0. So here V0, again V0 and V0. So this is off and this is off. Now we have to find the value of this x, right? Correct. So our case 3, this is case 1, this was case 1, this is case 2, this is case 3. Okay, what will happen now? Now can you write the equation? Now there is only one way to pass, like v input is connected here, v input, and v input is from 9 to some x, right? So now if you write the equation, what will happen? V naught minus v input upon 2.5, and what else? V naught minus 0 upon 5 equals to 0. What will be the value of v input now? 2 v naught minus 2 v input plus v naught equals to x0. So v naught is what? Here v naught is 2 upon 3 v input. Correct? Is it clear? Is it clear to everyone?
Yes, sir.
Okay. Now, what do you think? So this V out. Now the diode 1 has changed. It has been switched off, switched on. D2 also has been switched off, switched on. Now D3. D3 was off. It will be off till which value? Till which value of V0 this will be off? This V D3, what? To be off, to be in the reverse bias, right? D3 VD3 should be less than 0 volt, right? Correct? That means what? Till the V0 becomes 20 volt, this will be fine.
Yes, sir.
Are you able to understand it?
Yes, sir.
Correct, right? Because this was like
Yes,
this,
sir.
right? This was like this. Okay. As it will cross, this V0 will cross 20 volt. This will, earlier it was off, now it will be on. Correct? So till V0 becomes 20 volt, it will be switched off. So now this 2/3 V input, okay, as it is less than 20 volt, it is fine. This will be less than 0. That is fine. Now, what will be the value of V input? 30
30.
volt.
30.
Correct. So till 30, yeah, correct. Till 30, this combination is fine. As it will cross 30, so there will be a fourth condition, case 4. And what will happen? D1 is on already. D2 is off.
Off.
D3 will become on now.
On. Yes.
On, right? Earlier it was off. Earlier it was off. Now it will become on. Correct? Is it clear to everyone? Now the circuit will be what? This will be short circuited because this is on already. This will be on. This will be off. Okay, so we don't worry about the D2. D1 is already on. This is 2.5 kilo ohm. Now, what was the value? There is a resistance of 20 kilo ohm. And then this will be on now. So short circuited. And then you have 20 volt. And then you have a resistance here, 5 kilo ohm. Correct? And this is V0. Are you getting me? And you have attached V input. So now V input is from 30 volt to some X volt. Correct? So now, but every combination has been done. Now, see, and if you'll see, I'll just write it out. So this is also V0, this V0, this V0. So now, can you tell me the equation? At least the equation which it will be following. So V0
V0
minus V input
by 2.5.
2.5, correct. V0 minus
V0
20
minus
by
20.
20 kilo ohm, correct,
And V0 by 5.
equals to 0. Right. So now you can have an equation of V0. So you can have equation of V0. But here, see, now the issue is, see, what will happen? You can calculate the value of V input in, so this is 5, and if you'll just, you can get an equation, right? Whatever the equation that you'll be getting in the form of, let's for example, some slope S times 8 upon 30, sorry. This V, some slope S upon V input upon some constant C. Correct? This is what you'll be getting, right? V output in that form of V input. Okay. And what was the equation has been given? The equation was something like the V input was from 0 volt till 150 volt, right? So now, see, now what will happen? All the combination, all D1, D2, D3, you have already find that all the combination has been made. So earlier one of the diode was off, then on, off, on. So all has been done, right? So now from 30 to 150, because 150 was given, right? So 30 to 150, this will be following. Now if you want to write the transfer function, right? So in the starting, what happens if you want to write it? So this was, let's for example, this V naught. So this is V naught and this is V input. What will happen in the starting? What happened? Or maybe okay. So till from 0, let's for example, you write it as V input till 0 to which value? 3 volt, right? 3 value changes, then again to 9 changes, then 30 changes, and then it was 150. Correct? So till 0 to 3 volt, what was the output? The output was what? The output was 3 volt only, right? Till 3 volt, the output was what? 3 volt, right? So in the first condition, what happens in the first condition? When the value, when we have taken a very small value, what is the output that we were getting, right? 3 volt only, correct?
Sir, yes, sir, 3 volt.
Right? So here it will be 3 volt. Now from 3 to 9, what happens? That was the ratio was what? That V naught was somewhat proportional 0.5 times V input, correct? Somewhat the ratio, the slope will be 0.5, correct? And from 9 to 30, the slope was 2 upon 3, correct? So it will be 2 upon 3, somewhat like this. So 2 upon 3, that is 0.67, right? And then again from 30 to 150, again there was some slope S that I have written here. So you will be getting some slope S. Is it clear? Is the
Yes.
question clear to everyone? This is a very, yeah. So this is not going to ask anywhere. I don't know how they have asked you in the graded assignment or the practice, but nobody is going to ask you like this type of a question. Okay.
Okay, sir.
I hope this is clear to everyone. So what we'll do is, okay, I'll try to explain. So we'll go through the Jenner diagram, and that is important. Okay. So first, what I'll try to do is I'll explain the Jenner diode and then the transistor, and then we'll move tomorrow morning. Again, we have a session. We'll discuss the clamper. I hope after that it will be done this week 7, and then again we'll solve more problem on the BJT. At least BJT, I'll just give you a basic idea, and then we'll finish the clamper, and then again we'll, because BJT will be having some 8, 9, so we'll be having some 4, 5 session more on the BJT itself. Okay, on the transistor basically. Okay. Okay, I have one. So have you gone through the notes that I have shared? I guess that consists of all the circuit that I like. Have you gone through the notes or not?
So where?
So there is a group, right, that I have made yesterday. On the G space, I'm sharing the notes there. Even though I have uploaded on the portal also. So everyone has been added, right, to that G space group that we have created for EEC. So for the smooth conversation only, I have just created that.
Yes, sir. Yes, sir. I thought you were going to send it on a Discord, so I didn't saw the e-space.
Okay, no problem. So I have uploaded on the portal also, here also, maybe on the discourse also, but I guess everybody is here, right, in the G space. Okay, so okay, there is one question. If you want to try it out. Okay, so the question is, there is 2 diode. So you're applying some V input. The combination is such a way. So this is V input, this is V output. Let's attach a resistance here. This diode D1, this diode D2. Okay, this is the input that I'm giving. This is input. What will be the output?
In positive, D1 will get forward bias, and in negative half cycle, D2 will get reverse forward bias.
In
like
positive,
D1 will get forward biased in the positive half cycle, and in negative half cycle there will be no current because both will be in reverse bias.
both are in forward biased in a positive cycle. I want to say that.
Okay, so let's deal in the positive half cycle. What will happen? So during positive half cycle, what will happen? D1 will be on, correct?
Yes,
D1 is
sir.
on,
Yes, sir.
D2 is off, right?
Yes, sir.
What will be the equation? Minus V input. Okay, this will be short circuited, right?
Yes, sir.
Okay. So the current will go like this.
Sir, how D2 is off?
What?
How D2 is off? If we are solving the circuit, the wire is going up from the D2. There is no intersection point.
No. This is, see, you're attaching some positive voltage, right? This P is connected to positive, right? But here you can see that N is connected. Sorry. Okay, see. D2 will be also on. So whoever is said is correct.
Yes, sir.
D2 is also on. Okay.
How so?
This is connected. This is N is connected to negative, right?
Ah, okay, sir.
Right. So both will be short circuited in the positive
Yes,
half
sir.
cycle. What will be the equation? So minus V input and this whole
V in will be equals to V out.
V in upon R. V out is equal to V in upon R. I mean,
one second. So the current will go something like that. Will go here. So you can just you can just think of as a loop like this. The current will go like this.
ওকে পাঠিয়েছে ছেলেটা লোকটা
ছেলে না আমি কি করে জানবো
Okay.
ওনাকে মেসেজ
Well-
করলে
What will be the equation? So here you have a V input. You just think, right? This is how the current is going. So it will go like this, like this. What will be the equation?
V out is equal to V in.
V
V out
minus
is
V input equals
Minus
to
V.
V out.
Yes, sir.
Correct? Is it clear to everyone?
Yes, sir.
Yes, sir.
What about the negative half cycle?
Both will be in reverse bias.
Both will be reverse bias. That means what? V output will be 0. So what will be the output? It will go something like that and then 0. Is it clear to everyone?
Yes, sir.
Is this question clear? Yeah. Okay. Okay. Now let's move to the. Okay. Jenna, have you gone through the lectures?
Yes, sir.
Okay. See, what happens? I'm not going to tell you see, most of the part like the doping. How does generally you create that Jenna diode and all? You'll be going to learn in EDC. I just say that, see, what happens, you already know that how to create this PN junction and all, right? So Jenna diode basically is a type of a diode only, but there normally you dope a bit, like the doping is done as very high as compared to the normal doping. So what happens, whenever you are doing the doping, right? So whenever the doping level is very high, so the doping level is high, let's for example 1 is to 10 to the power 5, okay, then it becomes Zener diode. Whenever the doping is less, okay, let's for example 1 in 10 to the power 8 or 10 to the power 9 or 10 to the power 10, something like that, then you have a normal diode. See, the only difference here in the Zener diode, so the breakdown voltage for the Zener diode is much less as compared to the normal diode. Okay, if you have known the current, how the current general, basically I'm not going to deal with that. I just want to say that the breaking voltage, so breaking voltage for a Zener diode is much less in term of like 5-6 volts, something
Yeah.
like that, 5 to 10 volt. Okay, so and the breaking voltage for a, so breaking voltage generally is inversely proportional to the doping level. If you're doping very high, that means the breaking voltage will be much less compared. Okay, and if your doping is very low as you do in the normal diode, okay, that normal PN junction or a NP junction, okay, so there the doping is very less. So you have a normal diode, okay, and there you have a breaking voltage very high. Okay, that's why this will just behave as a forward bias or a reverse bias. This will behave a forward bias, a reverse bias, and then a reverse bias in breakdown voltage also. As you will keep on increasing the voltage, that you know, right? There's a diode, right? And you have a like some voltage across. If the voltage is positive, then you tell that this is working on a forward bias. If this voltage is negative, right, less than 0, then you tell that this is working in a reverse bias. But if the negative voltage is crossing some breakdown voltage, then it will behave like like if this is a Zener diode, okay, then it will start behaving like a like a voltage source itself. Okay, I'll just want to write. So see, there's like at least you must be knowing that whenever you are dealing with a Zener diode, if this is working in a breakdown voltage, if the potential across the Zener diode is crossing the breakdown voltage, then the voltage will work as a like a potential source, like a voltage source. Okay, there's a three I have in the notes also I have written. So Zener diode generally behaves like forward bias, same as you have to deal same as diode, like diode itself. It will work in reverse bias without breakdown. If the voltage potential across this is less than the breakdown voltage. Let's for example, if the potential is 5 volt, and if the voltage across this Zener diode is less than 5, then it will behave like a reverse bias, same as diode. The way you behave, like you deal with diode, right? The same way you will be dealing with the Zener diode also. The only difference here is this is the star mark, the reverse bias with in breakdown voltage. Just give me 1 second. Hello. Hello. Sorry for that. So what we were dealing, Zener diode will work in like it will work same as if it is in forward bias, it will work same similar to the diode that the normal diode that we deal. If it is in the reverse bias, like the potential is less than the breakdown voltage, it will behave like a reverse bias. Okay, without breakdown, it is same as like the way you deal the normal diode. And the third case is if it is working in a breakdown voltage with breakdown voltage. Okay, then it will work as a voltage source. Okay, is it clear? So if let's say example and the okay, so see let's say example you have a Zener diode. Okay, this is how generally this is P and this is N, right? Okay, this normal Zener diode. If it is in forward bias, right? That means the potential across this PN is positive. Okay, then it will be normal short circuit. If it is ideal, this will be normal short circuit, right? And if it is practical diode, then you just have to replace with a voltage source like this, right? Plus minus, correct? V cutoff. That you already know that, right? And there will be a current, ID current. That should be positive. Is it clear?
Yes, sir.
That will be zero. This is a normal diode. No, like behave like a normal if it is in forward bias. This practical Zener diode. Now, if it is reverse bias, then you already know that this will be behave like a same as the way reverse bias without breakdown. So it is not break like the voltage across this Zener diode has not crossed the breakdown voltage, then it will be behave like a reverse bias. Now, the last condition is if the potential across the Zener diode is more than the breakdown voltage, okay, then it will be behaving like a voltage source. Okay, then it will behave like a voltage source VZ. Okay, and you can attach a resistance also, even though the resistance is very small. If you'll see, if you know the graph, generally how does it behave? It will go something like that, right? And then here you have some IG. IG generally you call it as a knee current, right? And then at breakdown voltage, it goes something like that. So here, if you'll see the slope, this is I, this is current, this is voltage. So the slope, if you'll see that slope is what 1 upon R, right? And 1 upon R, if you'll see that is coming out to be infinite. So R is basically normally small in the form of, let's for example 5 to 10 or 100 ohm. Okay, so the resistance across the Zener diode, okay, that is coming out to be very small because you can see that from the plot itself. So I hope this much is clear. I'll maybe with us when we'll solve the questions, it will be more clear. Whenever you have a Zener diode, there can be three conditions, right? See, diode was having only two conditions. Normal diode that you deal in the Zener diode, that the only the third condition is whenever the reverse the potential across the Zener diode is more than the breakdown voltage. So if it is operating in breakdown voltage, you just have to replace the Zener diode with a potential source, okay, voltage source. Is it clear to everyone?
Yes, sir.
Okay. And one more thing. This is what, yeah.
So what is knee current in the Zener diode?
The small, see, knee current is in the through the Zener diode also, a current will pass, even though in the reverse bias also. This operating in a reverse bias with a breakdown, there will be a small current. Normally, we take it as a zero whenever we'll solve the problem, but mostly the value is very small. The knee current or the current through the the diode, like if you'll replace, if the Zener diode is working in breakdown voltage, so a small current also will come. IC will pass in the reverse bias also. What happens? See, there is a PN junction, some junction is there. Okay, so if you are if it is crossing the breaking voltage, right, so it will start conducting some current also in the opposite direction. So normally in the forward bias, what happens? It will conduct something like that, right? ID. Okay, it will be behaving like a short circuit. But if you are working in a reverse bias with a breakdown, like the voltage across them is crossing the breakdown voltage, it will start conducting a small current also. But that we don't have to do it basically. Okay.
Okay, sir.
Yeah. So, okay, so let's Normally you have to, so this work as a potential regulator, like voltage regulator across any, if you have to protect any devices, okay, you generally attach parallel in the shunt, you generally attach a Zener diode in the shunt, okay, to protect that device, right? If the voltage will cross some voltage, so that device is not able to, it's not capable, it can burn, right? So you can attach a Zener diode, right? So Zener diode will what, it will regulate the voltage, right? Input whatever you want to apply, so the output voltage will be whatever the volt, like the breakdown voltage of the like the Zener diode. So it will just be, so I'll give you an example that will help you. So this generally works, generally you use, even you use the BJT also as a regulator. Most of the time you use the Zener diode itself as a regulator. Okay, so the first example that I want to give you, let's for example, see Zener diode, even Zener diode can work as a clipper circuit also. Let's deal with that. So there is a resistance, R resistance. Let's for example, this is a Zener diode you have applied, and this is V naught. You're applying a V input here. The breakdown voltage is 5 volt. Your input that you are applying is 10 sin omega t. What will happen? Are you able to hear me?
Yes, sir.
Okay. What will happen? Okay, one more thing. I hope you have understood it or not. One more thing. See, potential, you see, there's a way, like both way is correct. If you want to see the potential across this diode, this Zener diode, like this plus minus, then you always be dealing with the, like let's for example, this is the diode that has been I have represented, right? If this, for this the breakdown voltage is what, 5 volt, so you can just take it as plus minus like this also, and this should not cross. If this is crossing 5 volt, this will be replaced with a potential voltage plus minus like this, because it is behaving like it is working in a Zener, like reverse bias, right? So the current also will pass like this, Ig. Okay, you already know it's working in a reverse bias. If it is a forward bias, the current would have been like this. Okay, and the potential in the forward bias, how do you replace the voltage? The knee voltage, not the knee voltage, the cutoff voltage, something like that, right? So the current, all, because this is a, like this is also a circuit, like the device like a resistor, right? The power dissipation will happen, right? So power dissipation, when the power dissipation happens in a resistance also, if a current is passing like this, always the current will go into the positive side if the device is a power dissipating device, or the power consuming device. Okay, so here also what I was trying to say is, even though if you are taking like this, if you are taking some positive, if you want to take this as a potential across the Zener diode, right, then then it will be difficult for you to think, like, because in this, like if you are taking plus minus like this, then it should not, the potential difference, like if you are taking this P as a plus and N as a minus, right, then the potential difference across this should be less than minus 5 volt, right? Because now it should not be crossing this breakdown. The breakdown is what, minus 5, if you are taking like that. But I would suggest you to always take, write N as plus side for a Zener diode, so that whenever you will replace this as a voltage source, you will directly write it as plus minus and the current as like this. Sorry, current like this, IC. But if you want to take it as the P junction itself as a plus, then you always have to think that, okay, this should not, the potential should be less than minus 5 volt. Are you getting me or not? Is it clear? Is it
Yes,
clear
sir.
or not?
Yes,
Yeah,
sir.
it's
But
clear, right? See,
it's work as a opposing battery
what opposing?
according to the polarity.
See, the polarity will be what? See, if you are taking plus and minus, this put the potential across this diode. If you are taking this plus and minus, if this is crossing 5 volt, then you directly because it is crossing the breaking voltage, right? So it will cross. You will replace with the potential like the voltage source like this, plus minus. Or if you want to write it as minus plus, okay, then you have to write it as minus 5 volt. Plus Because basically the breakdown voltage for this is minus 5 volt, right? Are you able to understand this or not?
Yes, sir.
Yeah, babe. So better every time you write it as the potential across the Zener diode from N to P. Okay, because see, earlier a diode was there, a normal diode was there. How do you calculate the potential VD1? If VD1 is less than 0, that means what? This is working in a reverse bias, right? If you are taking this as plus and minus, then VD should be positive, right? Are you getting me? Because if
Yes.
we're taking plus minus like this, that's why we were always saying that VD1 should be less than equals to 0 to work in a reverse bias. If you will take it as plus here, then VD1 should be positive, right? So that's why what I'm trying to say is for a Zener diode, you always take this as plus and minus. And this potential difference should be greater than 5, the breakdown voltage. Then this will work in a breakdown voltage. Okay, and then you can directly replace it with a voltage source. Is it clear to everyone or not?
Yes, sir. Yes.
Okay, so if this is clear, let's try to solve it out. How will you draw a transfer characteristic for like V output versus V input? How will you solve? This is a question 1. So V input is like this, right? This is 10 volt, this is 0, 10 volt. So this is 5 volt, this is 10 volt. What will happen? In the positive half cycle, what will happen? Till 0 to 5 volt, what will
0 to
happen?
5, it will follow sine wave, and then after 5, it will not. So, and it will get constant to 5.
Correct. So
Yes, sir.
till 0 to 5 volt in the positive half cycle, this will be working as a what?
As
This will
a
work as
hollow wave.
no. First, tell me this diode will work as what? In the positive from 0 to 5, how does it work? It'll be in reverse bias. It'll be in reverse bias till 5 volt. See, the potential across this volt should, if it will cross 5 volt, then this will work as a this work as a reverse bias with breakdown. If the potential across this the diode Zener diode is not crossing 5 volt, till that time it will work as a reverse bias only, right? Are you getting me?
Yes, sir.
Right, so till 0 to 5 volt this will work as a normal like reverse bias, so open circuit. So that means what? V output and V input will be same till 0 to 5, correct?
Yes,
Yeah.
sir.
Okay, now what will happen? As it will cross 5 volt, what will happen? It will be replaced with a potential of 5 volt, correct? So this will be something like that. See, this is V input. As it will cross 5 volt, this will be replaced with a potential source, right? So V output will be what? 5 volt, right? As it will cross the V input as crosses 5 volt. So see, let's for example, I'm taking 5.1 volt. So here it is 0, here it is 5.1 volt. So the difference is what? 5.1. It is crossing a breakdown, right? So now this diode, Zener diode is working in a breakdown voltage. So now if it is working in a breakdown voltage, you just have to replace with a voltage source of 5 volt. So V output will be equals to 5 volt. Is it making sense to everyone or not? Okay.
Yes, sir.
Okay. Okay. Then 5. Okay. Now from so till here it will cross. Again it will come 0 to 5 volt, right? So again it will be 0 to 5 volt. How does it will behave? Same, right? It will be reverse bias without breakdown. So again it will be same like that. What will happen in a negative half cycle?
E waves are forward biased.
Forward bias. If it is forward bias, what will be the voltage? V out?
V out
Five.
is equal to V.
No, it will be short circuit, right? If it is short circuit, the output will be 0.
Yes, sir. It's work as a V in
No.
it, V out.
Sir, please explain it again.
Okay.
V in will be V out, sir.
No, okay, I'll explain it again. Okay, this is, let's for example, this is 5 volt, this is 10 volt. Okay. Now what I'm trying to say is, as the V input, this is 5 volt, this is 10 volt. V input is from 0 to 5 volt. What did I say? This Zener diode can work into like 3 state. One in reverse bias, and in reverse bias it can work in 2 state: reverse bias without breakdown, and reverse bias with breakdown, and in forward bias. If I'm applying a potential from 0 to 5 volt, if it, let's for example, I'm applying 0.5 volt, okay, 0 to, this is between 0 to 5 volt. If I'm applying 0 to 5 volt, what will happen? The potential here, the difference will be the difference across this. See, this is P junction, this is N junction. For a diode, if N is attached to some positive, right, this will work in reverse bias, correct? So here also 0.5, that means a high voltage is attached to N junction, right? So that means what? This will work in reverse bias. Is this clear to everyone? This is clear, right? So in
Yes.
the starting, if correct, so in the starting it will work in reverse bias. Now I don't know whether it will work in breakdown voltage or not breakdown. So if the voltage is from 0 to 5, let's for example, this is 0.5, right? So here it is 0.5, here it is 0. What did I say? If the potential across a Zener diode is not crossing the breakdown voltage, it will work in reverse bias without breakdown. During that time, what will happen? It will be work as a normal diode. What does a normal breakdown, normal diode work? How does the normal diode work in a reverse bias? It will be an open circuit, correct? What did I say? See, here, what did I say? This is reverse bias without breakdown. This will work as an open circuit. If this is reverse bias in breakdown, if the voltage across that is crossing the breakdown voltage, it will, you just have to replace with a voltage source. Is it clear? So now 0 to 5 volt, as you can see that the voltage should cross 5 volt. If it will cross 5 volt, it will start working here, reverse bias with breakdown. So now from 0 to 5 volt, because the potential difference across the Zener diode is not crossing 5 volt, it will work in reverse bias without breakdown till 5 volt. So it will work without breakdown. That means what? It will be an open circuit. If it is open circuit, let's for example, you cut this both. What will happen? V input and V output will be same. Is it clear to everyone? Till 5 volt. Have you understood this or not?
Yes, sir.
Yes, sir.
Okay. Now till 0 to 5, it will be same. It will follow V input and V output are same. So V input equals to V output. Now it is crossing 5 volt. Now if it will cross 5 volt, what will happen? If it is crossing 5 volt, then what did I say? Let's for example, this is 7 volt. So now if it is 7 volt, so here it is 0, here it is 7 volt. Okay, if it is 7 volt here, the potential difference across the Zener diode is crossing 5 volt, right? Now the potential difference is how much? 7 volt. This is more than 5 volt. If this is more than 5 volt, it will work in reverse bias with breakdown. What will happen now? What should I do if it is crossing 5 volt?
It will be a voltage source of 5 volt.
Correct. It will be a voltage source. So you just have to replace with voltage source of 5 volt. So now you can see that V naught is what? V output is equals to 5 volt. I'll just draw the circuit. So now the circuit will look like, here it is, you have a resistance. You are replacing a Zener diode with a potential source, voltage source. Okay. And you just have to always remember, see, how do you replace if you have a Zener diode like this? You have to replace, so N should be positive like this. Here also you can see that the potential, the voltage source that you replace will be something like that. So here you have 5 volt. Now your V output will be what? You have a V input. You apply any V input. Your V output will be what? 5 volt only. Correct? Is this
Yes,
clear
sir.
to everyone?
Yes, sir.
Okay. So this V out. Okay. So V output will be 5 volt. Till when? Till the voltage is more than 5 volt. Again, if it is less than 5 volt, V input is less than 5 volt, what will happen? This again
Short
will be,
circuit.
it will start working as a
Open
reverse
circuit,
bias
sir,
without
open.
breakdown. Open circuit. This will be open circuit. This is reverse bias without breakdown. If it is open circuit, V output and V input will be same. So now V output and V input will be same. So it will follow the V, whatever the V input was. So V output will be same. Now, what happens in the negative half cycle? See, what
After
will happen in the
-5, it
negative
will be
half
0.
cycle? No, see, you have a Zener diode, something like that. Correct? Now you are applying plus here, minus here. Correct? So it can never cross 5 volt now. Any voltage that you apply here, it will never cross 5 because the potential will always be negative, right? Are you getting me?
Sir, as soon as the V in crosses -5 volt in the original polarity, the polarity given in the question, if the
Okay.
original polarity becomes less than -5 volt, then the Zener diode will be forward biased and it will act as a short circuit. Then V out will be 0, right?
I didn't get you. Can you explain me again? Tell me.
In the given question, the polarity is positive in upwards and negative is downwards. So as
Always take that. Always take that to remove the to do not have any confusion. Always take for if you are dealing with a Zener
Yes,
diode.
sir,
Always
yes,
take
sir.
N as positive. Okay.
And
Now the next question. Yeah. Go ahead.
after as the voltage reaches -5 volt and below it, like -5.1 or -5.2, then the Zener diode will get forward biased.
It will be in forward bias. Any negative
Then
voltage you give, it will always
that
be.
portion, that branch will be in short circuit. If it gets short circuited, then V out will be 0.
Yeah, it will be 0.
Yes, sir.
So
That's what.
till here to here, the negative half cycle, the potential will be 0. Again, from
No,
0
sir,
to 5, it
not
will
there,
start.
not at 0, but after like -5.
After
So
-5 also. Let's, for example, you are taking -7 volt. You took -7 volt, right? This potential plus minus should cross 5 volt. It is -7, right? If, let's for example, if you are getting confused, let's for example, you are taking this plus and this minus. So this plus minus, if you are taking, this is how much? 7 volt. But this, if you are taking this as plus and this as minus, then the potential difference should be less than -5 volt. Are you getting me? See, this is Zener diode. Whatever. This is Zener diode, right? Okay.
yes, sir.
This potential should be more than 5 volt. If you are attaching something like that, 7 volt, okay, this is fine. This will start working as reverse bias in breakdown. Now you are saying me, I am attaching like this. Now 7 volt. Correct?
Yes, sir.
But then also the potential difference across this is what? -7 volt, right? Sorry. The potential difference across this diode is how much? If you are taking the
-7,
direction
it
like
will be
this,
a positive upper side.
here, okay, this is what you are saying. This is what
Yes,
you are
sir.
saying, right?
Yes,
Okay.
yes.
Now you are taking this original version, right? So this is the original version. So now the potential difference should be less than -4 volt, 5 volt. But here you have a potential difference of 7 volt. Are you getting me?
Yes, sir.
Yeah. So if you are taking this as plus and this as minus, then the potential difference should be greater than 5 volt. But if you are taking this as plus and this as minus, then your potential difference should be less than -5 volt. Did you get the idea or not?
Yes, sir. Yes, I got it.
Okay. But see, everybody, I'm just reiterating it. You should not be taking, always take Zener diode if you are dealing, right? Always take N as plus and this as minus. So that while you are replacing the voltage source also, you will directly replace it like this, plus minus. Okay. Potential difference that you calculate across a Zener diode, always take N as positive N. So potential difference you calculate as Vn P, okay, for a Zener diode, and that should be whatever. Let's for example, it has been given 5 volt. So always the potential that has been given in the exam, like paper or in the any question, the voltage is given as V and P, voltage from N to P for a Zener diode always, okay. So here also in the exam, it will not be written minus 5 volt or something. It will just be given the breakdown voltage for a Zener diode is 5 volt. You have to take the potential difference as N to P. Is it clear to everyone? Is this question clear to everyone? Okay, so somebody was asking if in the negative half cycle what will happen. So in negative half cycle, this will be forward bias. This is clear, right? So if you'll just draw the circuit, this will be what? Like this. So V output will be what? V output is 0, correct? It's a short circuit, right? Is it clear to everyone? Is it clear? Not
Yes,
clear?
sir.
Clear, sir.
Okay. Okay. So if this is clear, let's move to the next question. Will you be okay? So I'm just what I'm trying to do is this will be more complex. So should I discuss? Okay, let's try it out. So you have a resistance R, Zener diode. The one difference here is same V input, V output. That is fine. V output. The one is the earlier case. In the earlier case, the Zener diode was ideal. Here, the Zener diode is practical. So that means you have a V cutoff also. Okay, V cutoff of 0.6 volt. Okay, and the Zener diode breakdown is 6 volt. Okay, if you are dealing with a Zener diode potential, this is plus and this is minus. If you have to write reverse bias with cutoff voltage, sorry, the forward bias with the cutoff voltage, you write it as plus here minus. This is V input, this is V output. You have some V input, you have to tell me the V output. How will it follow? Just think and then tell me. Okay, I'll just ask. Okay, from let's for example, this is 0 to 0.6 volt, and then you have 6 volt. Okay, from 0 to 0.6 volt, what will happen?
Open circuit.
The circuit will be open, reverse bias. Correct? How many of you are able to understand this? If the potential is from 0 to 0.6 volt, this diode will work as a reverse bias without breakdown. How many of you is agreeing with me? Okay. How many of you didn't understand that? Whatever we have like I've said. Till 0.6 volt, this diode will work in reverse bias without breakdown. Okay. What will happen if I'll increase the potential from 0.6 volt till 10 volt? What will happen?
Forward bias.
Forward bias. Correct. So this will be forward bias. This will be reverse bias. What will happen if I'll decrease? So what will happen here from 0 to minus 6 volt?
Reverse bias.
Reverse without breakdown, right? Same.
Yes,
Reverse
sir.
bias without breakdown. If I'll decrease further from 6 volt, minus 6 to further, it will be reverse bias
With
with
breakdown.
breakdown. Is it clear to everyone, or should I solve it Okay. From 0 to 0.6, from 0 to 0.6, the potential difference between from this P to N will be less than 0.6 volt. That means what? This will work in a reverse bias open circuit. Okay, open circuit means this will follow V output and V input will be same. Correct?
Yes, sir.
From 0.6 till 10, even though we'll keep on increasing the voltage, what will happen? It will be in the forward bias. It will be in the forward bias, right? Because
Yes, sir.
everyone is clear, right? This is plus and this is minus, right? So this
Yes.
will always be in forward bias. Forward bias, if it is in forward bias, that means what? What will happen? It will be a short circuit, but there will be a potential, right? Plus V output will be 0.6 volt. So this will be following 0.6. Again from 0 to 0.6, this will follow V output and V input will be same. Okay, I hope you're not able to understand this. How
Yes,
is
sir,
it
got
clear?
it.
So should I explain it like draw the circuit for each case, or is it fine?
Basically, it's a practical diode.
Yeah, it's a practical diode. I told you, right? It's a practical diode with 0.6 volt as a cutoff voltage. Till 0 to
0.6
0.6.
volt is the forward voltage drop and 6 volt is the reverse bias
Genuine.
breakdown voltage drop.
Correct. So now till 0 to 0.6 volt, right? Any voltage that you'll apply, the potential, the voltage across the diode VD1 is what, like less than 0.6 volt. That means what? This will work in a reverse bias. Be open circuit. If it is open circuit, V output and V input will be same. So it is following V output and V input is same. Now from 0.6 till whatever value that you increase, any value will be increasing. If it will crossing 0.6 volt, it will always be working in a forward bias. If it is working in a forward bias, you don't have to worry anything, right? Because in the reverse bias only, the Zener diode will get converted into, like Zener diode can have two state, okay, without and with breakdown. So in forward bias, there is no like state, like it will just be behaving like a normal diode. So if it is behaving like a normal diode, you just have to replace this with what? A potential of 0.6 volt. So V output will be what? 0.6 volt till here. Again, the voltage V input is less than 0.6 volt, right? So again, it will come in a reverse bias without breakdown. So V output and V input will same till here. Okay, now if your voltage is in negative half cycle, in the negative half cycle also, in the negative half, you can just think of as this will be plus and this will be minus. Even though this is plus and this is minus, the voltage across this diode from PNP is less than 6 volt. If it is less than 6 volt, again it is reverse bias without breakdown. So open circuit. That means what will follow? V output and V input.
Yes.
As it will cross 6 volt, that means minus less than minus 6 volt. Okay, let's for example, this is 7 volt. Now the potential VNP, the Zener diode, has more than 6 volt. That means what? This will get replaced with a plus minus, a voltage source of 6 volt. Right?
Yes.
That means V output will be what? V output will be minus 6 volt. Correct? So this will be like this. Is it clear to everyone or not? Not clear or clear? Should I explain it again?
Clear.
Clear. Okay. Anyone who didn't is able to understand it? Or...
Clear, sir.
Okay. So let's move to the next problem. So now we'll see that how it works as a voltage regulator. How does it regulates the voltage? Okay. So maybe I'll try to one more question. That'll be simple. So you have a volt V input. You have a resistance 50 ohm. You have a diode D1. You have a Zener diode. You have a resistance here 10 ohm, 100 ohm, sorry. and you have a voltage source of 15 volts. So you have a voltage source of 5 volt. Now you have to calculate the power dissipation across this 100 ohm. What do you have to calculate? Power dissipation. Use pen and paper and try to solve this. V input, you can take any. Breakdown voltage you need, right? The voltage breakdown is 5 volt. What else you need? This is ideal diode. How will you solve? Can somebody tell me how will you approach?
First, we'll find it for positive half cycle, then negative half cycle.
Correct. So for the positive half cycle, if you are giving a very less potential, what will happen? Whether D1 will be in a positive or a negative half cycle, like forward bias or reverse bias. D1. Sorry, D. Basically, you have only one diode, right? If you're just giving a very small voltage, what do you think?
Forward bias. Because it
Anyone
doesn't
else?
have
See, because
it doesn't have a cutoff voltage.
see, in the starting, I started with one problem, right? I have solved one problem, right? In the starting. In that problem, how did I assume that D1 was off? How did I assume? I told you at that time that I am taking V input as very small value. When I am taking this P junction is very small, and N, if you will see that there is a potential of 20 volt or 6 volt. If you will see, as compared to this 6 volt, this is very small V input, right? So that is how I thought D1 should be off, and then later we came with a conclusion that D1 was off in the starting when the voltage was very small. So similarly, here also you can think. That is the question. Okay. If you are applying the voltage very small, let's for example 0.1 volt. So the P is connected to very small volt, but the N has a higher voltage, right? 5 volt. So that means what? You can assume that D1 is off in the starting. Is it clear? See,
Yes, sir.
whatever you want to assume, you can assume it. Even though if you want to assume this has short circuit, that means open, then you should be coming out with a conclusion that the current that is passing through this diode is positive. If you are able to get that, then you can say that your assumption was correct. We can assume D1 as off because I thought, okay, V input you are giving a very small value. Here you have at N junction you have a higher value, 5 volt. Then I am assuming D1 as a off. Okay, so open circuit. And then if I am assuming this as an open circuit, I have to give a conclusion that VD1 is less than 0. If this is the potential across D1 is less than 0, our assumption is correct. If it is like if VD1 is coming out to be positive, then our assumption is wrong and this will be a forward bias. Are you getting me?
Yes, sir.
Correct? Okay. So now I'm taking this circuit itself. I'm taking this V input as very small. I'm thinking that D1 is off. If D1 is off, then I have to come with a conclusion also, right? If D1 is off, whether the VD1 is coming out to be positive, negative or not. That should support our assumption, right? The evidence
sir.
in the later part, if we'll calculate the VD1 is coming out to be negative, then only we can say that our the conclusion, whatever we concluded as correct. Correct, and then we have to check also if it in the starting voltage D1 was off, till which voltage till which voltage it will be on or off, whatever the assumption that we are making. Is it clear to everyone or not? Is it clear? Are you able? So what? See, in the positive half cycle itself, you have started with from 0, right? Now you have taken that, you think that, okay, D for the P side, it is connected to very small voltage. N side has a higher voltage as 5 volt, right? You thought, okay, D1 is off. That means what? You will replace it with open circuit. If you will replace it with the open circuit, what will happen? And what about the Zener diode? Okay, that also you have to think, right? If you are taking very small voltage, what will happen to the Zener diode? What do you think? In which state will it will work in the starting?
Reverse bias.
Reverse bias
Without
without breakdown.
breakdown.
Correct. So both of them will be off.
Off.
That means both of them will be open circuit, right? If both of them are open circuit, what will happen? Is there any current in the circuit?
No.
No, sir.
No current, right? Now, if you have to justify the assumption that you have made is correct or not, you have to like check also, right? Correct?
Yes, sir.
So now if you have to check the assumption, so let's for example, this is also open circuit, and here you have a 100 ohm resistance and you have a potential of 5 volt. This is what this voltage V Zener diode should be greater than equal, should be greater than 5. If this is greater than 5, right, and the current from this, see, if one second, so, and this is also VD1, and V input you are applying. We thought that both are working in reverse bias, correct? If both are working in the reverse bias, what should be getting? VD1 should be coming out to be negative value, right? Right?
Yes.
Yes, sir.
Okay. So V input, let's for example, this is connected to V input. So if we'll just write it down, what will be the value of VD1?
V in minus 5 volts.
V in minus 5 volt. Correct?
Yes, sir.
Yes, sir.
Okay. So this is VD1. And you already know that if this has to work, so you can take it till when this will be off. If it is less than
Till
0.
V in is less than 5.
So less than 5 volt, it will work as a reverse bias. Correct?
Yes.
Okay. Is it clear? So from 0 till which in the positive half cycle, from 0 to 5 volt, it will work in a reverse bias. Correct?
Yes.
Okay. Now, if it is working in a reverse bias, so the current is 0, right? What will be the power dissipation from 0 to, if the voltage is from 0 to 5 volt in the positive half cycle, 0 till 5 volt, what is the power dissipation in 100 ohm resistance?
0.
Correct? Now, if the voltage is more than 5 volt, what will happen?
T1 will get forward biased.
This will be forward bias. If this is forward bias, you have a diode also, Zener diode. Okay. Now what will happen? If this is short circuited 50 ohm, there is a current. This is more than 5 volt. This is V input is more than 5 volt. What will happen? Now the Zener diode will work in which state?
For that, we have to calculate the voltage at that node. So we need to first calculate the current. And
Okay.
then
If you-
using the voltage drop, we can find the node voltage.
Okay, see, one second, we input one more thing. No, are we doing something? So from the starting, we assume that both are working till 0 to 5 volt. We assume that this is open circuit, and that is coming out to be correct also, right? Okay. Okay, no. Okay, no. One more thing we have to think, right? So we have checked for VD1, correct? Did we check for when Zener diode? So Zener diode also we have to check, right? Okay. No, Zener for the, okay, one more thing. So we check for the V input till less than 5 volt. That is fine. This will be switched off. Okay, and after that will be switched on. What about the Zener diode?
Sir, as it gets switched on, then the potential at that node, which is connecting the VZD, that is Zener diode, and the D1, it will change. So we have to calculate that first. And to calculate that, there will be a current. Like if we assume the Zener diode is disconnected, that is open circuited, then and the D1 is short circuited, then there will be a current in the branch of D1 and the resistor. So there will be a potential drop
See,
in the resistor.
Okay, see, if there is a no current right here, because we thought that both are open, okay, that means what? The V Zener diode also, the potential is what? 5 volt, right?
Yes, sir.
Okay, so potential, if it is crossing 5 volt, then it will be replaced with a voltage source. And one more condition, that a current also, a knee current, like a current should also be going inside the Zener diode, correct? There is a IG, and that also should be greater than equals to 0. See, okay, one more thing I want to tell. For a Zener diode, the potential that you calculate should be greater than the breakdown voltage. This is 50%. One more condition should follow. The current IG should also be greater than 0. Then it is 100% sure that this is working a breakdown voltage. Okay, but even though with this, mostly we generally come to the conclusion that this is working a breakdown voltage. The current also, there should be a current IG should be going, okay, inside this Zener diode. Is it clear to everyone? So here also, so from the diode D1 we came to conclusion that the voltage from 0 to 5 volt, this is be off, and from 5 volt, if VIN crosses 5 volt, it will be switched on. Okay, now for the Zener diode, let's for example you're just replacing with some voltage Vx. Okay, 5 volt. So if let's for example IG, there is a current, because the current should also be coming, right? So if there is a current coming out, this should be Vx minus 5 by some 100. This is IG. That should be greater than 0. So here, from here also we are coming to the conclusion that if Vx is coming out to be more than 5 volt, this is working a breakdown voltage, correct? Okay, this is getting complex. Okay, should I explain it from starting or what? Is it clear to everyone, or should I explain it? Okay, let's work it from starting. Okay. So this was the problem, and then what I asked was the power dissipation across this 100 ohm resistance. So what I said is the voltage, you have to calculate the power dissipation. Okay, so power dissipation you have to calculate. First we started with the positive half cycle. In the positive half cycle, we started with a very small voltage, and then we have seen that if we are applying a very small voltage, the P will be connected to a very small voltage, but N will be connected to some higher voltage. Like here you have a 5 volt as a potential source, right? So then we assume that D1 is off. Okay, if D1 is off, that means D1 will be open, right? And then for the diode also, for the Zener diode also, we thought that this is open. Now if both are open, okay, both are working in a reverse bias, then we have to conclude that also. We have to have some evidence also that the potential across this diode is less than 0 and the potential across this also should be less than 0. Okay, then we started working on that and we came to the conclusion that VD1 is coming out to be V input minus 5. Okay, right? And if I'm giving, let's say example, I'm giving 1 volt, 2 volt, this VD1 is less than 0. That means this will be switched off only, reverse bias. Okay, so till when voltage? Till which voltage? 5 voltage. Okay, if V input is less than 5 voltage, then we are coming to a conclusion that this will be in reverse bias. Okay. Now for a Zener diode, what we have deal that the potential across the Zener diode VNP should be greater than equals to 5 volt. If it is greater than 5 volt, then it is working in a reverse bias with breakdown. If it is not, if it is less than that, then it is working in a reverse bias, normal reverse bias. Okay, so here also, and one more thing, a current should also be going. There should be a IG that should be going inside the Zener diode. Okay. Is it clear to everyone or not? So the first two, how we have assumed that the diode is off, and at after which voltage the diode will be on. Clear? See, if somebody, okay, I'll see. You just see the plot without doing anything. If you just see the graph, the circuit itself. If V input, what have we have calculated? Till V input is 5 volt, this is open, right? Okay, without solving, what should be the answer? Without doing anything, what do you think? What should be the answer? Even though this diode, let's for example, this Zener diode, if we'll increase the voltage from 5 volt till 5 volt, there was no current in the circuit. So power dissipation across the resistance will be 0. If we'll increase the voltage above 5 volt, what will happen? The Zener diode will start working in reverse bias with breakdown. If it is working in breakdown, that means what? The 5 volt and 5 volt, right? So is there any current will pass through 100 ohm? Will there be any current any time? No, right? How many of you have understood this, or you are not able to understand this? Did you understand this question or not? See, what did I calculated V input in the starting D1? We have thought that this is switched off because we were giving some small voltage, and then we saw that this was switched off. And then if we are assuming anything, we should be having some conclusion in the end. So we have calculated that V input, V output was VD1 was V input minus 5. If you will give some small voltage 1, 2, 3, 4 till 5, this is coming out to be negative. That means the assumption that we made was correct. Okay, V input minus 5. So V input, if it will cross 5 volt, then only it will be switched off. Sorry, it will start working in a forward bias, a short circuit. Okay, once it will, so let's for example, V input here give me more than 5 volt. This circuit will be what? This circuit will be V input with a short circuit. A resistance is there, a resistance, and then you have a Zener diode. See, if you are giving some more than 5 volt, if this will start working in a reverse, see, if the potential difference across this Zener diode is crossing 5 volt, what will happen? This will start working in a reverse bias with a breakdown, right? If this will work as a reverse bias with breakdown, what will happen? Here also you will be having, you will replace this with a potential voltage source, right? So here also you have 5 volt, here also you have 5 volt, right? So there won't be any current across this 100 ohm. So in that case, even though the voltage here is from 0 to 5 or from 5 to above, there won't be any current in this 100 ohm. Are you getting me or not?
Yes, sir,
Yes, sir.
getting.
Okay. And even though, so now if it is working in a negative half cycle, in the negative half cycle, what will happen? In the negative half cycle, it will always be off. See, if you are attaching any voltage, so in the negative half cycle, if you see that both of them will always be off, you can calculate that also. See, let's for example, both are off. I am assuming both are off. Okay, let's for example, I am assumed both are off. Again, the same thing, right? This potential and this VD1, VD. If you'll see V input is always we are working in negative half cycle, right? So this will be minus V input plus VD this how was the Zener diode? This okay. Okay, you just take this is how was it represented like ZT. So it will just minus V input plus VD plus 5 equals to 0, right? So VD is what? V input minus 5. V input that you are giving in a negative half cycle, right? Correct? So V input, if you are giving voltage in negative half cycle, that means what? This V input will always be negative value. If this is also negative and minus 5, so this VD will always be negative. So whatever the assumption that we have made, this will be open always. That's correct. So in the positive half cycle also we have seen that like below 5 it was off and above 5 it was on. Then this Zener diode was working in a reverse bias with a breakdown. So there was no current in this 100 ohm. And again we have seen that in the negative half cycle, VD will always be off. Okay, open circuit. And then this voltage will be what? The voltage across the Zener diode should be always be minus 5 volt. This should cross 5 volt, right? If it will cross 5 volt, then only this will work in a reverse bias with a with breakdown, right? Okay, so how many of you have understood this question in the
Yes,
negative
sir.
half cycle? Okay.
I have derived the equations, but haven't solved it. So I got 3 equations.
Okay. So 3 equation I means from 0 to 5 and then 5 to 10 and then in the negative half
Not
cycle.
equations, but 3 inequalities.
Okay. No, see, this can be solved, right? See, in the negative half cycle it was very simple, right? To see negative half cycle, just assume that both are open, and then you have calculated the VD. VD was coming out to be V input minus 5. You are giving negative voltage. That means what? The whole voltage will be negative. This is correct. The assumption. Now here, so the voltage across this is minus 5 volt. Okay, this is never any voltage that this will be always minus 5 volt, right? Minus 5 volt. This will not be working in a reverse bias with breakdown. Okay, that means what? There won't be any current anytime in this resistance. Okay, so if there won't be any current, there won't be any power dissipation across this 100 ohm. Okay, let's move from this. It just took a lot of time.
Sir, can I share my screen if you can tell if the equations are correct or not?
Yeah, you can share it. Hmm. So you have taken both are open, right? When
Yes, sir.
okay, both are open till 5 volt or after 5 volt.
Yeah, up till 5 volts, both will be open, and after 5 volts,
That is
the
correct.
D1 will get short circuited.
That will be short circuited, right?
So whatever I have done, it is after 5 volt, not before 5 volts.
Okay, after 5 volt. Okay, so after 5 volt, what will happen? This will be short circuited, right? Okay, just give me a second. After 5 volt, no, what have you done? Okay, this Vx you have calculated. Vx is coming out to be how much?
It is 1 upon 3 V in minus 5.
1 upon 3 V in minus 5. So you have done that. Okay, Zener diode is in forward bias. That is fine. Okay, you put any value. V input. Okay, that means for you the Zener it will work in a breakdown voltage when the V input minus 5. The equation seems correct. Oh no, this is why you have written T upon 100. Why is that 50 upon 100?
Sir, which one?
No, Vx ka value, how will be written?
The Vx value, it is the voltage, it is getting divided in the resistors, right?
Okay, so we have written across 50 upon 150. But you have to write across 100 ohm, right?
Actually, sir, first I am trying to get the voltage, and then after that I can use V upon R square formula.
That is correct. Okay, so okay, you want to
Basically,
calculate the
Vx upon R.
voltage before the 100 ohm. Okay, voltage before the 100 ohm, and that potential you are thinking that will be okay. So that will be so if if you write it in, what will be the value of V input? V input will be greater than what value?
Yes, sir, I haven't calculated it yet. Like I have to calculate that. Just
Okay, calculate it.
derive the three inequalities first.
Okay, so V input from there, how much you are getting? Is greater than 20, I guess, something like that. Okay, just give me a minute. I'll have 1 second. 1 second. See. Um, okay, see. 1 second. 1 second. See, Aniket, right? So even
Sir, what I am
first,
trying to do is that
no,
after
I got your.
assuming that VD1 is in short circuit, I am trying to find out when the Zener diode is in reverse bias and forward bias. That's what I am trying to do.
No, okay. So the first check for the positive half cycle itself, for the case one, when the V input is less than 5 volt. V input, when V input is less than 5 volt, the first diode will be off, right?
Yes, sir.
What about the Zener diode? Just write it that.
I like for the V input is less than 5. I haven't like calculated that. I am just trying to after 5 volt what it will be. I am trying to calculate that. After I calculate this greater than 5, then I can try for less than 5. So basically, I am dividing the problem into divisions. After 5,
No, that I got, but you will start it from 0 to 5, then you will move, right?
yes, sir.
Yeah, so 0 to 5, okay, diode is clear. Diode will be off and then it will be switched on. What about the Zener diode? Whether in which state will work? Before 5 volt.
Before 5 volt, it will be like the D1 will be open circuited, and so
Okay.
the Zener diode will also be in open circuit because 5 volt is there, right, across D1. Sorry, Zener diode. Both will be
Huh.
in reverse bias in 0 to 5.
Yeah, both will be in reverse bias, correct. Even though this is 5 volt only, even that will not cross 5 volt. If it is crossing 5 volt, then only you can think like whether it will work in a
Yes,
breakdown
sir.
or not.
Only
Because
after
it's
crossing 5, we can calculate something at least.
correct. So now,
That's what I
yeah,
am trying to do.
yeah. So now, okay, that's correct. So as you will increase V more than 5 volt, right? So the first will be short circuited. Similarly, the Zener diode directly will start working in breakdown voltage,
Yes, sir.
right?
But in what region of like after Vn greater than 5, there will be two regions of Zener diode. In one of them, it will behave in the reverse bias breakdown, and in another, it will be in reverse bias not breakdown. So I have to calculate that. So there are after the first equation, that is 1 by 3 Vn minus 5 greater than 0 or less than 0. After that, there are two equations also. So I have to solve for that two equations.
Okay, I'm just trying to tell you one thing. My screen visible, right?
Yes, sir.
See, as you said, when the V input first see 5 volt, less than 5 volt, this was open
Both
and
were
this was
open.
also open. Both were open. We came to know that VD1 was equals to how much? V input minus 5, correct?
Yes, sir.
And this was 100 ohm and this was plus minus 5 ohm. We know that I told you if this is a Zener diode, right? So this is
Sir,
NP, right?
there is
That means,
also 100 ohm there
yeah, 100 ohm.
and 50 ohms.
Okay, this is 50 ohm. Okay, so now the VNP should be crossing 5 volt, right? Correct?
Yes, sir.
Okay, so we have checked it that V input, if V input will cross V will cross 5 volt, this will be on. Okay, this will be
Yes,
a
sir.
short circuit. Now for VNP also we have to check.
Yes, sir. For
For VNP
VNP to
also.
check, we need to assume that it is in the VD1 is in short circuit.
Okay, no, we are assuming that this is open circuit as of now when V input is less than 5 volt. Now, while assuming that VNP should be
VNP
what?
is
Less
5
than 5
volt.
volt. Should be less than 5 volt. Now here it is 5 volt. Correct. See, VNP is 5 volt. Correct.
Hmm.
But one more thing, NP is 5 volt. But what did I say? There is two things. For a Zener diode to work in a reverse bias with breakdown, the voltage NP should be greater than equals to 5 volt. And one more thing, this IG should be greater than 0 ampere. So there should be a current to work this in a Zener diode.
Yes, sir.
To work this in a reverse bias with a breakdown. So here the VNP, see we assume that this is off, but our evidence also should be coming, right? That VNP should be greater than equals to 5 and the current should be passing. Both should be coming. So IG should also be coming out to be greater than 0. So IG should be what? Let's for example, this is VNP. So VNP minus 5 upon what? upon 100. This coming out to be correct. No, so it's wrong. There should be current like this now.
Sir, actually we cannot calculate the current in that way. So that's why I have calculated the voltage across NP, that is VNP. The Vx for my circuit is the VNP for you. So I am trying to get
Correct.
the VNP greater than some value or less than some value. Then only it will act as an forward bias or reverse bias.
Yeah, that whatever you are saying is correct. So you can calculate the potential here, and then whatever the potential that you are calculating here, if this is crossing, like if whatever you have calculated, right, you are crossing in such a way that here you are grounding, right? So Vx, if you are calculating, this Vs is crossing 5 volt, right? Then this will be in a reverse bias with breakdown. This is what you want to calculate, right?
Yes,
The
sir.
condition for Bx.
Yes.
Yeah, so I hope the equation
I
that you
am
have.
doing with voltage because we cannot find the current in VNP in this
No,
step.
I'm not finding current. I am finding a condition. We can find a condition, right? I can just think of as there is a current that is passing. Okay? And with a voltage
Yes.
source,
But sir,
I
you
can
have to
think
write
of as,
the current, right, in some form.
so I can write here, I can take VNP. I have here 5. So VNP minus 5 upon 100 should be greater than 0. So here from here also it is coming, right? VNP should be greater than 5 volt.
Yes, sir.
Correct?
Yes.
Yeah. So that is what I was trying to say. I hope you didn't got it. See, I will try to explain it again.
Yes, sir, I got it.
You got it, right? See,
Yes.
if this was working in a reverse bias, there is a difference, right? So reverse bias without breakdown and reverse bias with breakdown. If your Zener diode was like this, correct? Without breakdown, that means what? The potential VNP can be equals to breakdown, but if there should be a current also IG, right? Sorry, with like IG, sorry, there should be a here also without breakdown, the voltage across NP can be equals to breakdown, but this IG, if this is less than 0, so if let's for example this IG, if this is less than 0, then also this is not correct. Like this will be in breakdown without breakdown. For working in a breakdown, there should be a IG that should be greater than 0 with a potential of NP greater than equals to 5 volt, like whatever the volt, like the Zener diode, like breakdown voltage. Are you getting me? So here
Yes, sir.
also
Yes, I
this
got it.
NP, so VNP should be greater than 5 from here also. So I hope it's making clear, right? So for the positive cycle, we have calculated. For the negative, it was very simple. I hope it's clear. So let's move to the next problem. So if for any doubt, you can just ask me on the. So I'll just post the, like, maybe on the discourse. I'll just post the solution for this. Even though what I have discussed is correct. Clear? So there won't be, like, for the positive half cycle also there won't be any current across that 100 ohm. In the negative half cycle also there won't be any current in the half cycle. In the 100 ohm resistance. Clear to everyone? Okay, let's move
Yes,
to
sir.
the next problem. Even though it was a bit complex problem, nobody. Yeah. See, Zener diode, no? Zener diode generally works as your voltage regulator. Okay, so this is work as a helpful in regulator circuit. Okay, so your input can be anything, your output will be same. Okay, this generally like regulates your voltage. Okay, so here there can be two types of generator, like you can have a two type of a circuit. One circuit can be line regulation, or your circuit can be a load regulation. See what happens in the line regulation, your V input will be variable, but your V output regulation, what will happen, your RL, so V input will be constant. Here V input will be constant, but RL will be variable. So I'll just tell you, RL is the load resistance. I'll just draw the circuit that will help you to understand it. See, let's for example, you have a circuit. You have a Zener diode. Okay, you have a V input. This is variable. Okay, and then you have a load resistance also. This is also variable. Okay, so there will be a current IG. There will be a load current RL, IL, and then this is output. Plus plus minus V naught. This is V input, and this is okay. You can have, if you are varying input voltage. See, you can vary input voltage, or you can vary if you are varying the input voltage, then generally you call it as a line regulation. Basically, you are varying the input voltage, but then also you can see that, right? You can have a voltage, some range of voltage, right? That will work in such a way that this V input will make sure that your Zener diode will always be working in a reverse bias without breakdown. Correct? If this Zener diode is working in reverse bias without breakdown, with breakdown, So if you have a V input in some range in such a way that your Zener diode is working in reverse bias with breakdown, okay, then what will happen? This Zener diode will make sure that the output current, the load voltage is always constant. Is it clear to everyone? See, V input can lie from some V input max to V input some mean value. So there can be a range of V input in such a way that will make sure that this Zener diode is working in reverse bias with breakdown. If this Zener diode is working with breakdown, what will happen? This will work as a potential source, right? And this potential source will be same as V output. Are you able to understand this or not? Is everyone there? Are you able to understand this? Okay. Yeah. So if you are able to understand this, then it becomes very simple. See, I'll just deal with the first problem where your V input is variable. You are varying the V input. You have a resistance R input. Okay, you have a Zener diode. This is IL current. This is RL. So now what I'm doing is I'm fixing RL. I fix the value of load resistance. Just give me a second. Okay. Can you see the screen now? Can you see the screen? Is my screen visible to you?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So now what I was trying to say is V input is varying, right? V input, you are taking such a value such that you are making sure that the Zener diode is working in a reverse bias with breakdown. Okay. RL is fixed. Okay. You already know that there will be IG, and that is very small. I already told you the knee current for a Zener diode is very small. Okay. No, so the direction I am always writing is incorrect. This will go inside, so IG. Okay, here did I? Oh, it's correct. Fine. And there will be a current I input. Okay. Now, can somebody tell me if you have a V input in such a way that Zener diode is working in a reverse bias with breakdown, what will be the value of IL? If let's for example, this is VG, so the general breakdown is VZ. What will be the value for IL? IL will always be fixed, right? What will be the value of IL? What will be the value of IL?
IZ minus IN.
That will be fine. That is I input minus IG. That is fine. No, in term of voltage and resistance.
So is it
Not by
VZ upon RL?
Yeah, IL will be, yeah, correct. VZ by RL. Because if you are applying a voltage such that this Zener diode is working in a reverse bias, so this is working in reverse bias with breakdown. That means what? This you can replace. This you can replace with a voltage source, right? This is RL, this is VG, correct? And you have a current IL. Are you able to understand this?
Yes,
So that
sir.
means what? What will be the current? V upon
Yes,
RL,
sir.
right?
Yes, sir.
This is fixed. This is fixed. This is also fixed. So this will also be fixed. Correct? Okay. So now what did we get? VI input is equals to what? IL plus IZ. This IL is coming out to be fixed value, right? Because RL, we have said that the load resistance is fixed. If this is fixed and this is minimum, what will be the value of IN? IN will always be minimum, right? This is fixed. If IG is minimum, this I input will be minimum. If I input, this is maximum, then your I input also will be maximum. Correct? Can somebody calculate me the IN ka value? What will be the value of IN? IN will be what? V input minus VZ upon R input equals to IN. Correct?
Yes, sir.
So I input is what? V input upon when this will be minimum. So I input minimum will be V input minimum minus Vg upon R input. And similarly, I input maximum will be when V input maximum minus Vg upon R input. Is it making sense? So you can see that if the voltage V input is working in some like fixed value, right, some interval, in such a way that Zener diode is always in reverse bias with a reverse bias with breakdown, then you can see that the current through this RL will always be fixed. Correct? Okay. And similarly, if you will vary, there can be other condition also where your V input can be fixed. Okay. And you can have a resistance here with a Zener diode. And then you can have a RL can be variable. Okay. Okay. If so, this is R input. This again have a VZ. V input is such a way that VZ is working in reverse bias with breakdown. Okay. So you have a RL is variable. So again here also here you will be having IL. Here you will be having. Here also you will be having IZ. And here you will be having I input. Here also I input will be equals to IZ plus IL. If R is variable, what will be the value of IL? The IL will be same, right? What will be the value of IL? Vz upon RL. But RL is variable. If RL will be maximum, IL will be minimum. Correct? But I input will be fixed. Why this is fixed? Because V input that you are applying is fixed. So let's say example, I input is what? V input minus Vg upon R input. This is fixed. This is fixed. This is fixed. So I input will be fixed. In the first condition, what was happening? I input was variable because it was dependent on V input. Because you are varying V input. So this is the condition that you call it as line regulation. You are just changing the value of V input. In the second case, what is happening? You are changing the value of the load resistance itself. Okay, so there can be only two conditions where if you are like in a Zener diode when it is working on a voltage regulation circuit. In the first condition, what was happening? The input voltage was varying. You are varying the input voltage. If you are varying the input voltage, you can have I input minimum or maximum depending upon V input. In the second case, what is happening? Your V input, your current is from here it is coming out to be constant. Okay, so here it is fixed. This is variable. If RL is maximum, very high value, this IL will be minimum. If this is minimum, this will be maximum. Correct? And this is minimum, then this will be maximum. Is it clear to everyone?
Yes, sir.
Okay. Now, if this is clear, let's try it out. One question. So you have a voltage 12 volt. You have a resistance R. This is 5 volt. This is variable. And this is a variable such a way that the current through this IL is varying from 100 to 500 milliampere. Now you have to tell me the value of R. What did I say? Your input is fixed. This is the second condition. So your input is fixed. Your RL is varying. Okay? Or even though RL you can just think of as your current is varying. See, I'll just try to explain it in a simple way. This current across this resistance, load resistance is varying. What did I say? I input. This I input will be fixed or variable. First of all, tell me. This I input will be fixed or variable?
Fixed.
Okay.
Because
This will be fixed, right?
yes,
Because why?
because it's a voltage source is fixed. Here,
Voltage is
source is fixed. Input
correct,
voltage
correct.
is fixed.
Yeah. So input voltage is also fixed, and this is working in Zener diode condition. Like the Zener diode is working in the reverse bias
Without breakdown.
with breakdown.
With
Then
breakdown.
only it will be fixed, right? 12 minus 5 upon R. This will be I input. Okay, and this is fixed. 12 minus 5 upon R. R will be some fixed value. 12 minus 5 is some fixed value. So this is fixed. And this is I input is what? This will be going here IL and it will be coming here IZ. So this is equals to IL plus IZ. Correct?
Yes.
Is it clear? Right? So okay. So I told you, right? If this is minimum, this will be maximum. And if this is maximum, this will be minimum. Because this I input is fixed.
Yes, sir.
How many of you are able to understand this
Yes, sir.
question?
Yes, sir. Got
Yes,
it.
sir. Yes.
Yes, sir.
Okay. Now, what will be the range of IR? Can somebody tell me the range of this RL first? The range of this RL. I input IL, the current across this load resistance, minimum and maximum value is already been given. Okay. You have been told that this Zener diode is working in reverse bias with breakdown. Okay, what will be the range of RL? See, I told you, right? This is a circuit. If this is working in a Zener diode with a breakdown, so this you can just
Sir,
replace it with 5 volt.
IL will be 5 divided by RL, right?
Correct. So IL, when the IL, see, I is equal to what? V by R. So IL will be minimum when the RL will be maximum, right? So that is what RL is equals to V by IL. IL will be minimum, then RL will be maximum. So RL max is what? Equals to 5 volt upon the minimum current is how much? 100 milliampere, correct? Similarly,
Yes.
RL minimum will be how much? 5 volt upon 500 milliampere. So this will be what? 0.5 ohm. No, how much? This is how much? This is coming out to be how much? This, if
50
you
ohms.
just 10 to the power, if you just directly divide it, you'll get it in kilo ohm. I told you, right? In whole analog, like generally in diode or wherever you discuss, your whole resistance will coming out to be kilo ohm. If you are taking resistance in kilo ohm, current is microampere, then voltage will be always in volt. So here also it is volt, microampere will divide, you will get it in kilo ampere. Okay, so if you want to do in ohm, you can just
Sir, it is
write 10 to the
milliampere.
power minus 3. Sorry, milliampere, sorry. This is milliampere. Everywhere I am writing this is milliampere, not microampere. This is milliampere. Okay, so what will be the value that will be getting?
50 ohms.
50 ohm. Here it will be 10 ohm. Okay, so RL maximum you are getting 50 ohm, RL minimum you are getting 10 ohm. This is clear, right, to everyone?
Yes, sir.
Now you have to tell
Yes.
me the value of R. What will be the value of R?
Sir, it can be used like the voltage divider can be used for R.
See, this I
That is
input
12
is
minus
12
5
minus 5
upon
upon R.
R.
R. And this is fixed because 12 is fixed, 5 is fixed, so this is fixed. If
The
you use
IL
it,
is also known.
I input is equals to what? IL, right? IL is, if this is 100 milliampere, right, plus IG, correct? And this IG, if this is minimum, this will be maximum. Similarly, this is 500 plus IG minimum. This you are able to understand this, right? If this is minimum, this will be maximum because you are getting some fixed value here.
Yes, sir.
Are you able to understand this or not? Okay.
Yes, sir.
Okay. Okay. So what can be the IG, the minimum, what can be the value? I told you, right? The knee current is very small. You can take it as 0. If you will take it as 0, this I should have mentioned in the starting itself. So IG, the knee current for this uh, Zener diode will be 0. So this will be 15 minus 5 upon, what is this? 12 minus 5. 12 minus 5 upon R. What will be the value you will be getting? So 12 minus 5 upon 500 equals to R. So whatever value that will be getting will be the answer. How much you are getting? This is 500 milliampere, right? 12 volt. So you'll be getting something in kilo ohm. So if you want to write it in ohm, so you can just divide it by 1000. You will be having 7 upon 0.5 equals to 14 ohm as a resistance. Is it clear, or should I explain it again? Is this clear to everyone?
Yes, sir.
But sir, you haven't used the value of the RL, which we calculated in the previous step.
But that is of no use, right? I just calculated what can be the range of RA normally.
Okay.
If you have to calculate the value of R, you need basically you need just the current across I, like, because fixed value, some of the fixed value you need.
Yes, sir, got it.
Okay, so the next question I'll be giving. So if you want to solve it, here also the voltage is fixed, 10 volt. Let's for example, this is fixed. You have 50 ohm. Again, you have a Zener diode, and you have a resistance R. You have to calculate the minimum value of R so that the voltage across it doesn't fall below the 6 volt. So you can just think of as 6 volt. Minimum, you have to calculate the minimum value of R such that the voltage across this doesn't fall below 6 volt. Same thing, right? See, what will happen? V input is fixed. So you have some I input. You have some IL here. Oh, this is so much easier, right? How will you solve this? I input is equals to what? I in Zener diode plus this Ig plus IL. This I input is fixed. What is the I input? 10 minus 6 upon 50. If this is minimum, this will be maximum. If this is maximum, this will be minimum. Correct? You have to calculate what? R minimum. When can you calculate R minimum? V is equals to IR, right? V by I equals to R. If you have to calculate R minimum, this should be what? V by I should be what? So sorry, I should be what? If you have to calculate R minimum, I should be maximum. Are you able to? Okay, so okay. What do you think? What will be the value of? So I told you, right? I input, this I from here is getting divided into Ig and IL, and load current and the Zener diode current. Okay. And in the Zener I, we have to calculate what? The R minimum R calculate. You have to calculate the minimum value of the R. You already know that if this Zener diode is working in a reverse bias with breakdown, you just have to convert this into a voltage source. This will be 6 volt and you have a resistance R. Correct? This current IL will be what? IL will be 6 upon R. If you have to need this as a minimum, right? This should be maximum. Or if you need this minimum you need, right? R minimum you need. Then 6 upon I maximum. Correct? I maximum you need. That means what? The IL maximum, it should flow. When the IL maximum will flow? When the IG will be minimum. I told you, right? I input is what? Ig plus IL. If this is maximum, this will be minimum. IL maximum. That means what? Ig minimum you need. Correct? How many of you have understood? Or
Yes,
if
sir.
it is going,
Yes, sir.
if you okay. So then you can calculate the value of, right? So Ig minimum. Let's, for example, you can take any value. If not given, you can directly take it as 0 plus IL maximum. IL maximum is what? 6 upon R minimum. Okay, this will be what? 4 upon 50 equals to 6 upon R minimum. This you can just, R minimum will be 50 into 3 upon 2. 25 is 75 ohm. See, this is nothing. So see, Zener diode is pretty simple to understand. most it will work if, see, there can be three conditions, right? I told you whether it will be in forward bias or reverse bias without breakdown or forward bias with breakdown. As a regulator, it will always be working as reverse bias with breakdown, so that it will regulate the voltage. So because it will start working as a voltage source, that means what, it will apply that voltage source itself. So in the both the condition where either we were varying the V input or we were varying the RL, okay, in both the conditions we can see that when the Zener diode was working under reverse bias with a breakdown, it was making sure that across RL the voltage is constant. If the voltage is constant, right, you can calculate the IL. Okay, if you are varying the RL, if IL will vary, RL will vary. Okay, only one important thing you should be remembering is I input that is coming is constant, Ig plus IL. Okay, and this, if Ig is minimum, this IL will be maximum. If IL is maximum, this will be minimum. Okay, and this is how you have to solve every question. If any question is there where the Zener diode is working as a regulator, is it making sense?
Yes.
Okay. Okay, so I guess it's already more than 2.5 hours. We'll discuss, we'll have a session tomorrow morning again, right? Okay, so maybe tomorrow morning we'll discuss some of the more portion. Okay, so whatever we have discussed, have you understood it? Or maybe we can recap it again tomorrow. But have you understood it, like whatever we have discussed today? Is it helping you? If we are taking some extra session and all, is it helping you guys or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So is the Zener diode clear, or shall we again revise it tomorrow morning?
Zener diode clear.
Okay, then we'll solve some problem and then we will move to the BJT. Okay, is that fine?
Yes, sir.
Yes, sir.
Okay. Okay. So we'll start from BJT tomorrow and we'll solve some of the problems. Okay. For any doubt that you have, put it on the Discord, or maybe I have created the GA space, right? There also you can put. We'll try to solve. Whoever know the answer or solution, you can just put it there itself. Okay. So we'll try to make that interactive there itself. Okay. So
Okay,
you
sir.
have a quiz paper in coming 10 days itself. So we'll have some more session in the coming weeks. We'll try to discuss as many as problems so that you'll not be facing issue in the exam. Okay. Okay. Thanks. Thank you, everyone. Yeah, tomorrow we'll be discussing BJT. Yeah.
Thank you, sir.
Okay,
Thank you,
sir.
sir.
Thank you.
Sir.
Thanks, everyone for joining me. Thank you. Bye.